Good morning, everyone, and it's great to see people again in real life. And thank you for the organizers for inviting me for this talk. And I'm Rahul. I'm from AutoGrid Systems, a company we started almost 10 years ago to this date, with the sole purpose of bringing clean, reliable, and efficient energy solutions into the market by building virtual power plants. So today, as we go through this talk, we are going to go on a little journey. We are going to imagine the future. Now, every one of you have seen some of these pictures of doom and gloom, and some of you have actually had the unfortunate case of living through some of them. Effectively, deep power cuts because of uncontrollable wildfires, intensifying storms all around the world, and this picture needs no introduction. But what I want to do today is actually imagine a future where all these pictures belong to its rightful place, that is, in the history books. We are no longer contending with the daily problems of climate change. We have solved them once and for all. Now, that future is long, it's arduous, and it's tough, but it's completely realizable. And in order to go on that journey, I am going to specifically talk about one way of tackling climate change, that of replacing peaker plants. Now, what are peaker plants? Now, peaker plants are an age-old way of tackling peak net demand on the grid. Specifically on days, summer days when it's hot, or even during winter when you have a severe cold front approaching, you would switch on these power plants for a short amount of time to meet the peak demand of the grid. And now, with more renewables coming onto the grid as well, if there is a shortfall of renewables, you also switch on these power plants. But the fact of the matter is, these peakers are tremendously polluting. They're super expensive because they only run for a very short amount of time, and more devastatingly, they have a deep impact on the disadvantaged communities. There are thousands of these peakers in the United States alone, and if you don't believe me, take a look. Now, the left-hand side, the left-hand graph is actually quite easy to understand. Yes, there are peakers around the state of Texas. Yes, they are situated all around. And yes, there are even more peakers that are proposed to be built. But what is most concerning is the graph on the right-hand side. So what this graph shows you is that the biggest and the dirtiest peakers are actually co-located in areas where you have the maximum minority population and the maximum low-income population. So not only do we have a problem with climate change with these peaker plants from their emissions, but we also have a central equity issue. So how do we solve this problem? Since we are all here imagining the future, and any futurist who needs to be taken seriously, the answer always lies with the Cybertruck. But all jokes aside, all the trucks that you see over here have enough juice in them to not only power your homes, but also they could provide grid support in case of all these emergency situations. And therefore, instead of turning on dirty peaker plants, you could actually use the more than 100 kWh batteries which each of these trucks carry around. You buy these trucks because they are fun to drive. But what if you could also use the same trucks to provide grid support during emergencies and get paid for it? Not only is this possible, but we are actually doing it with a variety of different assets, whether it be solar plus storage, whether it be EVs, water heaters, thermostats, chiller plants, HVAC, you name it. So that is essentially what is a virtual power plant or a VPP. a logical combination of all these different kinds of distributed assets in a way that it resembles exactly like a power plant, a virtual power plant. So how do you participate in a virtual power plant? There are two primary modes. The first one is if you are a utility or a new energy provider, you could essentially look at using a virtual power plant platform, which is nothing but an open, vendor-agnostic optimization platform, which is able to bring on all these kinds of different grid assets very seamlessly in an organized way. Now, this requires the development of certain software technologies, optimization techniques, which I'm not going to get into the details of, but this is a very powerful way of abstracting out individual assets to get to realizing a VPP. And the second very interesting way of engaging with a VPP is if you are an asset owner, is this particularly interesting business model. So if you own assets, whether it be an EV fleet or a solar plus storage fleet or even large-scale renewables, you can directly engage with providers such as ourselves and get paid for some extra utilization of your assets where we provide grid support. We, on the other hand, take all your assets and stack them so that it resembles exactly like a peaker plant and take it either to a wholesale market or to a utility and offer them capacity and therefore unlock more revenue. So this sets up a virtuous cycle by which we are able to deliver VPP solutions at a way more cost-effective way than an effective peaker. I would like to draw your attention to this particular stack chart, where not only are we providing VPPs at a cheaper rate, but also if you see, the most expensive part of a VPP is something called customer payments. So this is where you pay your customers to use their assets, and they, on the other hand, are encouraged to adopt more and more cleaner assets, whether it be EVs or solar on their rooftops. So that is what I mean by setting up a virtuous cycle. And if you're looking at numbers, we are actually better off than most peaker plants out there. In some cases, we are reaching grid parity. But what is interesting with this graph is that blue line is eventually going to go down lower and lower as we learn more and more, and some of the costs do keep coming down. But the dynamic which plays out over here is as the blue line goes down, we use the peakers less and less. So they become more and more expensive, and therefore you would see a movement of all the right dots which are right now below the blue line become more and more expensive and go above it. So effectively, this is the economic cycle we are setting up with using virtual power plants. And as more and more assets come online, we are able to optimize them in a much better fashion so that they eventually start resembling exactly like an equivalent power plant. So you know what they say. If it looks like a power plant, if it walks like a power plant, if it talks like a power plant, it is a virtual power plant. But all of this is not actually theory. This is right now getting adopted worldwide. The market trends are there. Many of the countries, geographically distributed, are leapfrogging into using VPPs as a key decarbonization strategy. We alone, last year, were able to dispatch over 1,800 events worldwide through our VPP platform. And you can imagine the amount of impact it has in terms of not turning on these dirty power plants elsewhere. And closer to home, some of the leading energy companies are also using VPPs as a central decarbonization strategy. So at the end of this journey, where does this leave us? So I started with a dirty truth, and now it's time to come back with a clean slate. The economics are there, the technology are there, the people are there, they're all in this room. So there is nothing preventing us from engaging and therefore replacing this dirty fuel burning power plants everywhere. So together, we can all work for a cleaner, more reliable, and cheaper energy future. Have a great conference, everyone, and we'll be around to answer any questions that we may have. We'll be located outside and happy to talk about this in more detail. Thank you.